everything looks good. All right. The circle graph shows the number of votes received by each candidate during the school election. Find the percent of students who voted for candidate C. So what we need to do first is we need to find the whole group of candidates. So we've got 36 plus 60 plus 54, and 36 plus 54 plus 60. That's going to give us 10, 9, yep. All right, so that's going to give us 150. Now, out of those, we want the percent, so we'll want a P for candidate C. So candidate C then becomes our part. So 36 is going to be the part. So we're working on the percent equation, so P percent times the whole. The part is 36. We don't know the percent, so we put that P over 100 times 150. So now, to undo the division, we multiply both sides by 100. And that gives us 3,600 equals 150p. We're going to divide both sides by 150. I'm just not going to be able to write that very well because I used up too much space. And then I'm going to use the calculator off screen. I hope you don't mind. If you do, sorry, but that's all I've got. So here we go. 3,600 divided by 150 gives me 24. So P is 24%. So next one, 0.8%, that's P. Of 150, that's the whole. What number? A. So we go A equals, now 0.8%, when I change 0.8% into a decimal by dividing it by 100, I get 0.008. So we have 0.008 times 150. And so we multiply these. 0.008 times 150 gives me 1.2. 0.5% is P. Of what number is W? Is A. So we've got 12 equals. Now, again, 0.5 divided by 100 gives us 0.005. So 0.005 times W. We're going to divide both sides. Oh, I wrote down 1.5 and I meant 1.2. Wow. Duh. I'm like, something's not right. I'm tired. So we go 12 divided by 0.005, and I get W is 2,400. Number 4, what percent? So P of 300 W is A. So we're going to go 51 equals P over 100, because we need to change the percent to a decimal, times 300. So I'm going to multiply both sides by 100 first. So that gives me 5,100 equals 300 times P. So we divide both sides by 300. And so P equals 17%. Then 120% of what number is 102? So here we have P, we have W, and we have A. So we're looking at 102 equals, well, 120 divided by 100 is 1.2. So we have 1.2 times W. So we divide both sides by 1.2. And let's see what we get. 102 divided by 1.2 gives us 85. Told you not to do 6 or 7 because you guys didn't have this sentence here. So, but if you wanted to stop and see them now, 35% of 20, this is correct. Everything's good. As far as this one goes, unless the math's wrong, I'm going to double check that here. 0.35 times 20, that indeed is 7. This one here is wrong because they've got 30 in the front, and 30 should actually be in the back. And then we would divide both sides by 0.6. Or I guess I just said that backwards. 30 is the part, not the whole. And so this would be 30 divided by 0.6, which gives us 50. Number 8, the sales tax on the model rocket is shown is $1.92. That's the part. Down here, the $24 is the whole. We want to find the percent. So we go $1.92 equals P percent, so that's P over 100 times 24. So we multiply both sides by 100 first. That gives us 192 equals 24P. We divide both sides by 24. And so we look, 192 divided by 24 is 8. So 8% sales tax. There were N signers of the Declaration of Independence. The youngest was Edward Rutledge, who was X years old. The oldest was Benjamin Franklin, who was Y years old. So we've got X is 25% of 104. What was Rutledge's age? So X is our part. So that's A, or sorry, let's just do X. Sorry. So X is 25%. 25% as a decimal is 0.25. And then times 104. So we have X, Rutledge's age, is 0.25 times 104. So Rutledge was 26 years old. Now 7 is 10% of Y. So this is A, this is P, this is W. So we're looking at 7 is 10%. 10% is 0.1 times W. So we undo this by division. Dividing 7 by 0.1 gives you 70. So Franklin was 70 years old. N is 80% of Y. How many signers were there? So we look at this. N is A, percent is P, and then this is W. Now we know Y. We know Y is 70. We just saw that from the last problem. So we've got N equals 80% is 0.8 as a decimal times 70. 0.8 times 70 is 56. So we have 56 signers. How can you tell whether a percent of a number will be greater than, less than, or equal to the number? Well, let's just give an example of this. If we said 100% of 50, then we know that's going to be 50. So 100% means that the value is going to be equal. Whereas if I did 20% of 50, that means that I'm going to be smaller. So if we're less than 100%, that means that the number is smaller. Smaller. Whereas on the other hand, if we did something like 150% of 50, that means that the resulting value is going to be greater than 100. So when we're greater than 100%, the number is greater. So here's where we start having to put our thinking caps on. In a survey, a group of students asked their favorite sport. 18 of the students chose other. Here's what I'm going to bet. I'm going to bet that a lot of people don't read this word 18. So 18 students chose the other. Now, how many students participate in the survey? Well, that seems like a question that's out of left field. Get it? Sports joke. So the idea is that we need to actually find the remaining percent, and then we can use the 18 to find the whole. So we're going to go 100, because that's how much there is in total, minus 40, minus 37.5. So 100 minus 40 minus 37.5. That gives us 22.5%. So what we know is we know that 18 is 22.5% of those surveyed. And with that sentence, we crack open the problem, because we can go 18 is 22% as a decimal is 0.225, and then we don't know the whole. We undo multiplication with division. So we go 18 divided by 0.225. That gives us 80. So what we know then is 80 people were surveyed. Now, how many chose football? Well, we look here. Here's the picture for football, and it's 37.5%. So we know that we want to find out what number is 35% of 80. So we're going to go A equals 37.5% is 0.375 of 80. So times 80. So we're going to go 0.375 times 80. And that's 30. So 30 chose football. All right. Tell whether the statement is true or false. Explain your reasoning. If W is 25% of Z, then the ratio of Z to W is 75 to 25. That's a cool question. So it might be easiest to stop and pick some numbers that we know would be true, and see if that works. If you don't like that, the other idea would be to try to do some algebra. But if we think this through here, if W is 25% of Z, so let's just think about that. Can you think of a number where W is 25% of Z? If you can't, let's just go ahead and pick the simplest of numbers, which would be, well, I'm just trying to think this through here. Sorry, I am stalling, because I'm thinking about the best way to show you this. Well, let's simplify this ratio first. If you divide both these numbers by 21, you get 3 to 1. So the question then is, would that ratio let's take a look at some numbers. Let's just pick let's just pick 20. Oh, yeah, duh. I know what to do. Okay, sorry. It just took me a moment. It's the end of the day. So we know that W is 0.25 of Z. And so if we were to, and Z to W means Z divided by W, which Z to W is 75 over 25, so Z to W is 70, Z divided by W is 75 over 25, which is 3 to 1. So, gotcha. So, if we divide 0.25 to both sides, gotcha. Z will equal, if you divide 1 by 0.25, you get 4, so that's 4W. And if we divide by W to both sides to get that Z over W, then we would see that Z over W should actually be 4 to 1, not 3 to 1. There we go. So this is false. Another way to do this, you could have just grabbed two numbers that you knew were like, if you go 100%, well, 100 for Z and 25 is W, because 25% of 100 is 25, you could see that that would be 25, that would be 100 to 25. And so that would be a counterexample. So there's a couple things here real quick. So what I've done here is I've provided a counterexample. What I did over here was I provided a proof. So the proof is by far the more elegant way of doing things, but the counterexample is straight and to the point. So anyway, at a restaurant, the amount of your bill before taxes and tips is $19.83. A 6% sales tax is applied to your bill, and you leave a tip equal to 19% of the original amount. Use mental math to estimate the total amount of the money you pay. Explain your reasoning. Okay, mental math. I'm not going to use a calculator. It says use 10% of the original amount. So 10%, I know that 10% of 1983 is $1.98. I'm going to ignore the 0.3 of a cent. Now, if I look here, the sales tax is going to be applied to this value, and they do the 19% also applied to this value. So in total, we're doing 6 plus 19, which is 25. So we're putting 25% on there. So mentally, now I'm going to just remember that this is 2 cents short of $2. So that'll come in handy. So I'm going to take this up to $2. So what that means is that 10% is $2, 20% would be $4. I don't know why I keep writing a colon, $4. And so 25 would be $5. Now, at 10%, I'm actually 2 cents short. So at 20 cents, I'm 4 cents short. And at $5, 25%, I would be 5 cents short. So what we're going to do is we're going to go 1983 plus $5, because that's the easiest way to do this. So 83, 24, 83. But then, like I said, I'm 5 cents over. So I'm just going to take 5 cents off of that. So that's $24.78. Now, I know it says mental math, but that doesn't mean I can't write things down. It just means don't try to use a calculator, in my opinion. So I'm just double checking my work here. So according to the calculator, I'm 1 cent off. I'm 1 cent short because of the extra 3/10 of a cent. But we wanted an estimate. I mean, you could even estimate this to be $20 and make it even easier on yourself if you wanted to. Anyway, enough time. Table shows your test results in a math class. What score do you need on the last test to earn 90% of the total points on the test? Okay, so we need the total points. The total points, we're going to add that up. 100 plus 25, well, 250 plus 150 plus 300. And so that would be 100 plus 250 plus 150 plus 300. So we've got a total of 800 points to be earned. Now, we want a 90%. So we need to find out what 90% of 800 is. Well, it so happens that 90% of 800 is 720. So we need to have 720 points in full. Now, they give us test scores, they don't give us points. So what we can do quickly is we can figure out the amount of points we have for each of these. So 83% of 100 is 83. 91.6% of 250. 0.916 times 250, that's 229 points. 88% of 150. That's 132 points. So now we're going to add all of these up. So 83 plus 229 plus 135 is 447 points. So you've earned 447 points. What score do you need on the last test to earn a 90%? So you're going to go 720 minus 447. I feel like there may have been another way to do this problem, but I chose the path that I'm on, and I'm not going to back down. So I need 273 points, and so 273 is some sort of percent of 300. So we multiply both sides by 100. That's 27300 equals 300. Dividing both sides by 300, that's going to give us 91%. So we need to get a 91% on that test. Like I said, I feel like I should have been able to do this in a different way, but off the top of my head, I don't know what that way would have been. So, yeah. All right, so review. Use a proportion to solve. What number is 120 of 80? So we're just cross multiplying here, so that's 100A equals, well, it said disconnected and then reconnected. So am I still going? It looks like I'm still going. Okay, I don't know how much I lost. I'll have to take a look at that. So that's 9,600. We then divide both sides by 100. So A equals 9.6, or 96, sorry, not 9.6. Kind of thrown off by that disconnect error. Find the distance between these two numbers. If you recall, we find the distance by the absolute value, and we subtract the two numbers. So when we subtract a negative, that's keep, change, change. We need a common denominator. The best common denominator here would be 10. So we're going to make this negative 5 and 4/10 plus 1 and 3/10. 5 minus 1 is 4, and 4 minus 3 is 1. And then we're going to divide, so that's 4 and 1/10. Then we want to find the distance between negative 4.3 and 7.5. So keep, change, change. That's an 8 at the end. That's an 11. So this is negative 11.8. So that's 11.8 is the distance. And the last problem, there are 160 people in a grade. The ratio of boys to girls is 3 to 5. Which proportion can you use to find the number of boys? So boys to girl is 3 to 5. So I'm going 3 to 5. And there's 160 kids in the grade. So there lies the trick, is that if the ratio of boys to girls is 3 to 5, that means that the ratio of boys to all the students is 3 to 8. And so then the boys over 160. So this would be the right answer, which is this one right here. All right, hope this helps. Thanks.